Here are the solutions to review assignment number 17. I think we can do it in the book. Let's see. And so you're given a function and then questions about it. The domain of the derivative is open from A to B. So I see this corner right here. So there's definitely one that is undefined in terms of that interval. It's continuous, that's true. This is a continuous function. So I got it. The derivative of f is positive on the open interval from A to C. So from A to C, is it positive? Is it rising from A to C? Yes. So the answer is 2 and 3. Done. All right, let's look at the next one. This looks like the y2 minus y1 x2. This looks like the original definition of a derivative, right? And so if that's the case, then cosine is what we're taking the derivative of. So what's the derivative of cosine? It's sine, and it's negative sine, and then plug in pi over 2. So I recognize the form of it, that it is a derivative form. So I know we're doing the derivative, and we're doing the derivative of cosine. So that's negative sine and plugging in pi over 2. And so at pi over 2, it's the unit circle. It's up here, so it's 1, but that makes it negative 1. So the answer is A. Number 3, at which of the 5 points on the right are the derivative and the second derivative negative? Try it. This is a great question. So the derivative is negative if it's going down. So it can't be that one. Can't be that 0 and that one. So those are not. So there's 2 that are going down. Then the next question is negative. For that means it's in the middle of concave down or concave up. So this one is in concave up territory. So the only one that's negative and concave down at the same time is B. Number 4. Try it first. Press pause. Why not? The slope of the tangent curve here at 2, 1 is what? Man, this is going to take another piece of paper. So I'm going to do it on another piece of paper. So do it on another piece of paper, only the ones that you have to. So on that separate piece of paper, go ahead, write that down. Okay, for this one, I was trying to save you from it. This is number 4. I have to take the derivative implicitly. That's good practice. This is the product rule. The first times the derivative of the second plus the second times the derivative of the first with a hook. Same thing with this one. The first times the derivative of the second plus the second times the derivative of the first with a hook, and then 6 is 0. So I recognize my y primes, and that this is 3xy squared. This one is 2x squared y. Oops, 2x squared y. And then everything else is going to subtract. So this is going to subtract. This is going to subtract. And then divide. See if we can make that simple and not a headache. Then I plug in the point, which is 2, 1. So wherever there's an x is 2, y is 1. So that's going to be negative. Negative, so it's going to be 2, and then 1. It's going to be 2, and then 1. And then 2, and then 1. So plug it all in and then make sure we do it right. So negative 1, this is minus 4, so I get negative 5. This is 6 plus 8. So I get negative 5 over 14. Any answer looks like? Oh, I got it. So it's C. Yay. All right, number 5. Let's see if I can do that one in the book. Which of the following statements about this function is true? It has no relative extrema. So I'm going to take the derivative. That's 4x cubed minus 6x squared equal to 0. You can divide out a 2x squared. That leaves me with 2x minus 3. And so at 0, the signs don't change, but at 3 over 2, because of the odd multiplicity, it's definitely going to have something, either a max or min. We can figure it out if we need to know. So if I draw a number line for here, we have one for 0 and one for positive 3 over 2. And then if I put in -1, it's a positive times a negative. Or if I put in 1, it's a positive times a negative. And then here's where the sign changes. So there's just a minimum to begin with. So the function has 2 relative extrema. That's not true. The function has 1 relative, 2, and 3. So the only one that could match, even without that, I think is C. Let me just check to make sure I did it right. That's right. So I don't even have to check concavity for points of inflection, because if I just check that there's 1 turning point, that'd be it. If you want to about point of inflection, you have to take the derivative again, equal to 0, and draw a number line. All right, number 6. I think we can answer it right here. What's the derivative here? So remember, this is like it's squared, like so. So the derivative is going to have a 2 in front. Then I'm going to copy everything. And then subtract 1 to the exponent, and then the hook. So the derivative of sine is cosine, copy. And then one more time, the derivative of negative x is -1. So remember, there's actually 2 hooks here. Then plug 0 in everywhere. So if I do that, plug in 0, I get 2, first of all, times -1. So I feel like there's a -2 in front. And then 0 means sine 3 times cosine 3. Well, that answer's right here. Done. So the answer to 6 is B. The solution to the diffie Q, where is which one of these? Oh, that's going to take a piece of paper. Let's try this again, number 7. We just did this on the last review assignment. Can you solve the diffie Q? So we're going to separate the variables. This one actually isn't too bad. No logarithms or anything. Add 1 to the exponent and divide. Add 1 to the exponent and divide plus c. And we have a 0.23. So 3 cubed is 27. Divided by 3 is 9. 2 to the 4 is 16. Divided by 4 is 4. So that means c must equal 5. So we have y cubed over 3 equals x to the 4th over 4 plus 5. And then I'm going to multiply everything times 3. And then I'm going to do the cube root of all of that. Okay, so that's the answer I get. And that answer matches with E. That's one I got. See if that's true or not, looking at an answer key. It is. Hooray. Okay, let's do the next one, number 8. I'm just going to write it down here. So for number 8, we're integrating x minus 1 times the square root of x dx. This feels like I'm going to, then we're going to distribute. So I'm going to multiply this. So this is like x here. Let me rearrange it. It's like x to the 1/2 times x minus 1. So that when I multiply, I add the exponent. So 1/2 plus 1, I add them. X to the 1 times -1 is just negative x to the 1/2. Now, we can actually just add 1 to the exponent. So 3 plus 2, and then the reciprocal. Same thing here, 1 plus 2, that's 3. And then the reciprocal, and then plus c. So we have 2/5. X to the 5 minus 2/3 plus c. Hey, the answer is D. Done. Number 9. See if I can do that here. So it has a graph for number 9. I like little graphs. So this is velocity. So according to the graph, at what time does the bug change direction? Well, when the velocity changes signs, obviously. So the answer is that. According to the graph, at what time t is the speed of the bug the greatest? So speed could be right here. We're saying, that velocity is 3, or right down here, because it's the absolute value of velocity. Which one's bigger? And the answer is here. So the absolute value of -4 is 4. So the answer is, at what time? At 10. What's the right end behavior of this? So it's not connected to this anymore. Power term over power term. That's -1/4. You know that one, right? The area of the region in the first quadrant. Oh boy, that's going to be one where I'm going to graph. I got to do something for it. Okay, number 12. I don't mind. I like doing this work. I know that, whatever. I like doing the work. Now, if I'm going to put in a positive number, I'm going to use common sense that I can only use numbers from 0 to 4. So why is that? Because if I plug in a number, 0 to 2, because if I plug in 3 or 4 or 5, it's going to be a negative answer at the square root sign. So 0 and 2 are my intercepts. Anything after that's going to be something that's undefined. If I plug in 1, I get 1 times the square root of 3, which is, up here somewhere. But it's going to look kind of like this. And it says to find the what? The area, right here. So to find that area, we're going to integrate from 0 to 2. And we're going to integrate this. I'm going to write it calculus friendly. The hook of this is negative 2x. It matches like terms, which is nice. And then what was it over what it became? So it's negative a half. The hook is not part of the answer, so we start with negative a half. And then I add 1 to the exponent and then multiply times the reciprocal. And that's going from 0 to 2. I know the 2's cross out. I'm going to have to simplify this as I go on. That negative 1/3 can just stay in front. I'm going to plug in 2. Well, 2 squared, take away, that's 0. Subtract. I'm going to plug in 0. That gives me 4. So the square root of 4 is 2, and 2 cubed is 8. So if I put all of this together, I get positive 8/3. So the answer is B. That's the area. Pretty good, right? Number 13. Maybe we can do this one in the book. So you're going to take a picture of the work you did on page and the book, put it all in there, and get 100%. Which of the following is an antiderivatives of this? So antiderivative, let's see how we're going to do this. This is like 1 over x ln x squared. So if I see it that way, then the hook is already there, and all I have to do is add 1 to the exponent and divide. So this is good. This is plus 6, so I mean whatever C is, right? And this one doesn't look like it's good at all. So it could be 1 and 2. I say C. Make sure I'm right. Perfect. Number 4. Is this one where I need another piece of paper? So I have a derivative. Y equals 5, x equals 0. So then what does y equal? So I'm going to do the antiderivative here. So I'm going to separate the variables. So I'm going to divide by y. See if I have room here. And I'm going to multiply by dx. When I do this, this is going to be a logarithm. The antiderivative of secant squared is tangent. That's a rule you need to know. Then it's going to be e to the tangent. Oh, 0,5. Let's do that. So if I plug in 0 for x, tangent 0 is 0. So that's just ln 5 is what c is. It's multiple choice, so you can make a mess of it. So this is just ln 5. So why not make it messy as long as you get the right answer? So that when I get y by itself here, this is going to multiply by 5 in front. So 5e to the tangent x. 5e to the tangent, perfect, right there is the answer. All right, number 15. I need a calculator. So what am I going to put in the calculator? Average value. Let's just go straight to it. I didn't even write it down. So I'm going to need a fraction. I know I'm integrating, right? We're getting stronger at this. And then the bounds go from -1 to 1. And I'm going to integrate that function, e to the negative x squared. And then subtract by the diff. So 1 take away -1 is actually 2. I get 0.74, perfect, done. Right? Doesn't have to take long. All right, let's do this one. This is just the setup. The volume generated revolving around the region enclosed by the graphs y equals 2x. I need a graph. And 2x squared. Now, all of them, I got to make them equal to each other. I already know x equals 1, right? Because 2 times 1, 2 times 1 squared, it's going to go 0 to 1. So this one's wrong. This one's wrong. 2, if I plug in 2, oh, I guess it could be 2 as well, right? So there's actually 2, are there 2 regions enclosed? Do I have to double the answer? There's 2 regions enclosed, right? And double the answer? Is it going to be C, where you double the answer? C, C, C. Number 16? No, it's B. This one. All right, so enclosed by it, 2 is also, no, because 2 squared is 4 times 2 is 8. No. So it goes 0 to 1. Ugh, no good. So the difference between this one and this one. So it's going to revolve around the x-axis. There's a space there. So there are 2 radii that I'm subtracting. And what's on the top and bottom? So 2x is on top and 2x squared is on the bottom. So this is 4x squared minus 4x to the 4th. Perfect. It's B. All right. Let B be defined as follows, or F be defined. Which of the following is true about F? The limit exists. So it actually doesn't matter what this one is for the limit. It just matters this one. And does that limit exist as it approaches A? So if I plug in A, I get, yeah, because it's x plus A, x minus A. These are removable. So if I plug in A, the answer is 2A. So yes, the limit exists. F at A exists. It does. F at A is equal to 0. It's continuous there. Not true unless A equals 0. So at the top, the answer is x plus A. And at the bottom, it's 0. And when you plug in A, you get 2A. And when you plug in A here, you get 0. So unless A is 0, then it's not continuous at A. That's what I'm sticking to. So 1 and 2, we're good. All right, let this be the function. The second derivative is always negative from 1 to 2, with selected values shown here. Which of the following must be true about the derivative at 1.2? So what do we know so far about this? Is that it is increasing. So we know that the derivative is increasing, so this can't be it. So this is like it's concave down and increasing. I'm going to pick that one because that's what it says to pick. So we actually have to find the slopes, to find the slopes between points. So if I find the slope here, if I go 4.38, subtract 4.18, divided by, subtract these, that's 0.1, I get the answer 2. If I go here, 4.56, subtract 4.38, again divided by 0.1, I get the answer 1.8. The slopes are decreasing because it's concave down. So that means this slope at 1 must be greater than 2 in terms of it. So we have 2 and then it goes to 2. Perfect. So it equals the slope at 1.2. All right, 2 particles. I'm moving on. Start at the origin and move along the x-axis. Their respective position functions are given. For how many values of t do the particles have the same velocity? So for velocity, I need the velocity of 1, that's cosine t. The velocity of 2, that's e to the negative 2t times negative 2. And then we make them equal to each other from 0 to 10 and see what the answer is. So if you make them equal to each other and do it, you'll see that with a calculator. Here, let's do that. Let's see if that's true. I won't just look at the answer key. So we're going to graph. I have something here, so I'm going to get rid of it. And then I'm going to press tab and then start typing. So I have cosine t, or cosine x. And I have what's the other one? Negative 2 e to the negative 2x. And this is from 0 to 10. So I'm going to change the menu. Oops, not that one. The window. From 0 to 10. Oh, sorry, it's negative 1 to 3. Haha. Let's try that again. Menu, window, negative 1 to 3. There, I got 1 point of intersection now. Jeez. All right, menu. How do you find the intersection? Do it with me. Analyze. Do it with me. Intersection. 4. Perfect. Press down, and then highlight over it, and what's the answer? There it is. 1.645. What? So I had cosine t x negative 2e. Did I do it right? Let's try again. So I had cosine x and then negative 2e to the negative 2x. And I made them equal to each other. Oh, so for how many does it have it from 0 to 10? I'm looking at like two different ones. So from 0 to 10, how many times did it cross each other? Jeez Louise. Now I'm like, okay, I think I'm at it now. So from 0 to 10, how many times do they intersect? How many times do they equal to each other? So like 1, 2, 3. I see it now. It crosses 3 times. It's 3. It's that one, D. I don't know what, this is like garbage. Okay, now let's go to this one. So the function's defined like this. This already feels like the fundamental theorem of calculus. So if I take the derivative, they cross out, x gets plugged in. So g has a local minimum. So that means take the derivative. So just plug in. So it's sine x squared. That's it. And then make it equal to 0. And then see which one of these it goes above or below. So again, I'm going to graph that sine x squared. So tab. I'm going to erase this and then type in sine x squared. I'm going to get rid of the second one. And it goes from negative 1 to 3. That one goes from negative 1 to 3. And now look at it and go, okay, where is there a minimum? And when it goes from negative to positive. So right here at 2 point something. So I'm going to go menu, analyze the 0. And I want to know what that 0 is right there. Highlight over it, and I get 2.506. That's this one right here. 2.506. Round it to 2.50. Make sure you see it. Oh, come on. All right, there it is right there. And that matches with E. All right, 21. The graphs of 5 functions are shown below. Which of the functions has a non-zero average value? That would mean like here, area above equals the area below. No. The area above equals the area below. No. Here, this area, does it match these two areas? It kind of looks like it does. No. The area above, does it match the area below? Is it? Yes. All right, so which is the only one? This is clearly the answer. The area above does not match the area below, so that means the average value would not be 0. Because when you integrate, the answer is going to be 0 if the area below matches the area above. Okay. The region in the first quadrant enclosed by the y-axis in these graphs is rotated about the x-axis. Find the volume. So rotation means this. So we have cosine and y equals x, and that's the area, and it's rotated around the x-axis. So there's going to be a little space. There's going to be 2 in terms of it. So it's pi. I need to know where they intersect. So I'm going to type in cosine. I'm going to get rid of this. So cosine x. Is it still blurry? And the other one is y equals x. And then I just want to know where they cross. So menu, analyze, intersection, number 4. So to the left and then to the right, highlight over it, and that number is 0.739. So it's 0.739. It's pi. There's 2 radii here. So what's above and what's below? So above is cosine, and that would be subtract 0, what you're revolving around, and then below the smaller radius is the line, subtract 0, which is just x, and then type that in your calculator. And if you type that in your calculator, you get 1.520. All right, oil is leaking from a tanker at this rate. T is measured. How much oil has leaked out? Super easy question after 10 hours. So you just integrate from 0 to 10. That equation. Oops, 0 to 10. 2,000. You type this in. E to the negative 2t dt. That's it. Just type that in the calculator. That simple. Then you get 8,647 gallons. See if I'm right. This is how much. This is an integration question. They give you the bounds. They give you the rate. Just type it all in and it's done. F is continuous for all of x. Which of the following integrals necessarily have the same value? So from A to B, this one or this one. So for 24, anyways, the answer is this one. One and 2. Right? So the answer is A. All right, we're going to let that one go. 25. The derivative of f equals g. And h is equal to x squared. So what is this? So this is the derivative of the outside times the derivative of the inside. So the derivative of f is equal to g. So that's just g, h at x, times the derivative of h at x. And then x squared and we know the derivative of that is 2x. So I think it's going to be 2x times the derivative so this is g at 2x times g at x squared. So this is just g at that. So the derivative of that is just g times the derivative of h, and then times 2x to put it together, and that would give me d as an answer for 25. All right, last one, 26. A particle moves along the axis, so its velocity is given here. The total distance, easy question. We're going to integrate from where to where? 0 to 2. Total distance is absolute value. Plug that in, use your calculator, and it's over. Try. So plug that in, use absolute value bars around it, go for it, and press pause. See if you get the same answer as me. All right, Mr. G Math, over and out. Great job reviewing today. Till next time, I'm proud of you.